Hi, Gary Zacharias here with the Apologist bookshelf. Has science really squeezed God into a corner and killed him off with all of its explanations? Is atheism really the only intellectually tenable position? And if you try to reintroduce God, is that going to impede the progress of science? Well, John Lennox, one of my favorite people, says let's take a look at those claims very carefully. He's got a book out called God's Undertaker, which is a great title. And the subtitle, Has Science Buried God? And this is the updated edition, so it's not the original. This one came out in, let's see if I can find it here, 2009. So it's a little bit older, but a lot of the information here is good because it's still in effect. I've done 2 or 3 previous podcasts, and again, you can just go to Podbean and look them up if you want to see some of the other things we've talked about there. I would like to do, I think, out of all the chapters, gosh, so many good ones here. How about we take a look at chapter 7, The Origin of Life? That's always good, isn't it? People scratch their heads about that one. Here's the start. Quote from Stuart Kaufman. Anyone who tells you that he or she knows how life started on the earth some 3.45 billion years ago is a fool or a knave. Nobody knows. And then here's a quote from Antony Flew. He was one of the best-known atheists who had a lot of people looking to him for good arguments for atheism. And as he was introduced to the whole concept of intelligent design, he changed his mind. And he believed there was some kind of God before he died. Now, was he a Christian? I don't know. Not sure. But he did jump a lot from atheism to some idea of intelligent design because of the arguments that were made there. So let's take a look. He starts off, he talks about the complexity of the living cell. He said the first thing we need to do in this chapter is just to get some idea of how vastly complex the living cell is. And then he wants to take a look at DNA. So let me tell you again, we've talked about this before, but there are so many good computer videos of what's going on in the cell. Take a look at them sometime. I think one's called Voyage Inside the Cell. Just amazing things that are happening there. It's a city, and the things that go on and the movement and the pathways that are created and all the cellular processes, just mind-boggling. You know, in Darwin's time, they looked at the cell and they said, well, what is this? It's just a little glob of protoplasm, and you need it, yeah, and it's got a nucleus in the middle, but looks pretty basic, kind of a bag. Well, now, of course, they've changed their mind. So he starts off, he says, let's talk about the complexity of the living cell. He quotes Michael Denton, who's a geneticist. He says, the break between the non-living and the living world, here's the quote, represents the most dramatic and fundamental of all the discontinuities of nature. He said between a living cell and the most highly organized non-biological system, he said maybe a crystal or a snowflake, he said there's a chasm as vast and absolute as it's possible to conceive. Even the tiniest of bacterial cells, Lennox says, that weighs less than a trillionth of a gram, and now he's back to Denton again, is a veritable micro-miniaturized factory containing thousands of exquisitely designed pieces of intricate molecular machinery, made up altogether of 100,000 million atoms, far more complicated than any machine built by man and absolutely without parallel in the non-living world. And I just wanted to stop there and have us think about that. You're taking just a tiny bacterial cell, one of the most basic forms of life. And he says it's a factory, and it's got machinery. And he says way more complicated than anything we can build. Isn't that wild? All right, so he says the size and the structure and the design of this machinery, he says pretty much the same in all cells. So no living system can be thought of as primitive or ancestral with regard to any other system. So how do you find the ancestor? They all seem to be doing well right now, and there's not much of a hint of an evolutionary sequence among all these diverse cells on Earth. And he mentions a Nobel Prize winner, Jacques Monod, M-O-N-O-D. Here's what he says. We have no idea what the structure of a primitive cell might have been. The simplest living system known to us, he calls it the bacterial cell again, he said in its overall chemical plan, it's the same as all other living beings. It has the same genetic code, has the same mechanism of translation as human cells. One more sentence from Manad. Thus, the simplest cells available to us for study have nothing primitive about them. No vestiges of truly primitive structures are discernible. Isn't that interesting? So you can't find any kind of ancestors. They're all doing what they ought to do right now. He talks about irreducible complexity in the next section here. He said these cells are like factories. They have all these assembly lines are made up of large protein machines, highly coordinated moving parts. He said you have a living cell inside of it, maybe 100 million proteins of 20,000 different types. But he said that cell, says a couple of hundred could be placed at the dot at the period for their sentence in this book here. So here we go. Let's take a look at Michael Behe. That's the person he's going to turn to next. He's a biochemist. And he says for Behe, it looks like there's design. And of course, he gives that famous design, and I'm sure you've seen examples of it. You can find it on the internet, of the bacterial flagellum. It's a propeller-like device that spins around and allows the bacteria to swim through some kind of material. And this motor, it says, if you laid 35,000 end to end, they would take up only 1 millimeter. So what are these little motors like? Well, they're made of 40 protein parts. They have a rotor, a stator, bushings, and a drive shaft. And Behe is pointing out that if you just took away one of those parts, it's not that the motor wouldn't work as well. It would not work at all. So he calls that irreducible complexity. So what does that term mean? A single system composed of several parts that help something function, and that if you took any one of those parts, it would cause it to cease functioning completely. And you see that the same in a mousetrap. So if you have a mousetrap, if you just lay a wooden bar out there, you're not going to catch any mice. If you lay a spring on it, that still won't catch any mice. You have to have 5 or 6 parts all hooked up in a particular way if you really want to catch any mice. So he says that seems like a real challenge to evolutionary theory. And even Darwin said this: if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. Let me think about that. Let me have you think about that. He said, if you could come along and show some kind of complex organ, whether it was the eye or liver or something, any kind of object like that, that couldn't have been formed by successive slight modifications, a little bit, and then a little bit more, and then a little bit more, and then ta-da, you have your eye. He says the theory would break down. And Behe talks about how many irreducibly complex molecular machines are out there. And he says there's no publication in scientific literature that describes how you could evolve a molecular machine. How could a biochemical system produce that? He says we're not finding that. And he even takes on James Shapiro, who's a biochemist at the University of Chicago. He admits that there is no detailed Darwinian account to evolve and talk about how you evolve a biochemical or cellular system. It's just wishful speculations. It says even a critical review of Behe by another person concedes, yeah, there's no detailed biochemical model for this. So Behe is arguing the existence of irreducible complexity at the molecular machine level, pointing to, and here's his result of all of his research, intelligent design. So it wasn't just the laws of nature or chance or necessity. These were all planned. And Behe says his conclusions come from the data, not from some secular book. He's not starting with looking at the Bible and trying to jam the evidence to work with the Bible. He says, just looking at what's out there. He says, all right, so next section. What about the building blocks of life? How do you get molecular machines? Well, they're made from proteins. And they're made out of the basic building blocks of living systems, amino acids. 20 of them are in living organisms. So the question comes pretty obviously, molecular machines made out of proteins, proteins are made out of amino acids, how did they arise? And you remember it was that famous Miller-Urey experiment in the 1950s, where a guy took gases that they thought were part of the early Earth and zapped them with electric discharges like a little spark, and they found some amino acids. They were so exciting. They said, this is it. This is euphoric, right? This is how you got life here. Well, not so fast. Now, geochemists are saying the early Earth's atmosphere is not the way Miller thought of it back then. And so now amino acids really couldn't be formed in the kind of atmosphere that people think occurred on the early Earth. In fact, they believe now that the atmosphere of the early Earth would actually have been hostile to the formation of amino acids. So there's a lot of information here about how they have to be particularly right, the kind of amino acids. Paul Davies, he's a physicist, he says there are immense thermodynamic problems to produce the right chains of amino acids to form peptides. So it's really, really difficult to do it. Yeah, and then here's another problem with it. According to current estimates, there really isn't much time. You think, oh, you got billions and billions of years. Yeah, but when the Earth was formed, within a billion years, you already have life in these very old rocks. So you don't have multiple billions of years. You've got to get life going pretty quickly. He says another problem is how you get proteins to form. It says if you're going to have a protein, the amino acids that make them up have to be in exactly the right places in the chain. So he says, think of it like amino acids are like letters of the alphabet. So the protein is a really long word in that alphabet. And every letter, amino acid letter, has to be in the right place. So you can't just snap amino acids together in any kind of form you want and make a protein. So the order is the vital thing, not just the fact that they're there. And so I like this, he quotes Sir Fred Hoyle, talking about how hard that would be to produce life spontaneously. Hoyle said it's kind of like the same chance you'd get if a tornado swept through a junkyard and produced a Boeing 747 jet aircraft. Yeah, good point. Okay, so I'm going to move along here through the chapter. He's got some more information here. He said basically the big problem, he says it got more difficulties. The core problem is not producing the kind of order that you get like in a crystal or a honeycomb. You got to produce something involving like language formed by the complex order of the amino acids to form the protein. So living things are instructed by their DNA. So it's like computer code. And so the order of a living cell derives from some kind of internal control. Where do you get the information? It says it's information that lies at the heart of the problem. Sir Francis Crick, not exactly sympathetic to the Judeo-Christian idea of a God, he said the origin of life seems almost to be a miracle. So many are the conditions which would have had to have been satisfied to get it going. And then he has that quote from Stuart Kaufman of the Santa Fe Institute. Anyone who tells you he or she knows how life started on the earth some 3.45 billion years ago is a fool or a knave. Nobody knows. Now, they also have a quote here from Francis Collins. He said, how did self-replicating organisms arrive in the first place? It's fair to say at the present time, we simply do not know. No current hypothesis comes close to explaining how in the space of a mere 150 million years, the prebiotic environment that existed on planet Earth gave rise to life. And then he continues, that's not to say that reasonable hypotheses have not been put forward, but their statistical probability of accounting for the development of life still seems remote. So that's chapter 7. And then the next chapter covers DNA, the genetic code and its origin, and spends time on that. And so I have done chapter 8 in a previous podcast. You might want to take a look at that. So this gives you an idea of the book. I might just go through real quickly with the chapters again. One was War of the Worldviews. I've done that in a podcast. Number 2, second chapter, and I want to do this someday, the scope and limits of science. Does science really explain everything? Is that all we need? Science? That's called scientism, and he talks about that in that chapter. Designer universe, that's one chapter. Designer biosphere, the nature and scope of evolution. Oh, so he's going to take on evolution. Yeah. We just did the origin of life. That was chapter 7. Chapter 8, the genetic code and its origin. I did that one. 9, matters of information. So we're trying to figure out how you get information there. And he spent several chapters on that. So, good book. I think you might like it. It can be, a little difficult in spots with the science, but that's really terrific stuff. I mean, we need to know this. And maybe not memorize it, but at least have a book like this around so we can share it with friends. Not a huge book, easy to read. A man in the Guardian did a review of it. He said there's no more important debate than this, science versus religion. But it needs to begin, again, with a clear understanding of what science and religion actually are. Lennox has done this wonderfully. Another woman wrote a review and said, an excoriating demolition of Dawkins' overreach from biology into religion. So you knew that Dawkins was going to come into this. He does pretty often because he's so outspoken when it comes to issues of religion and science. Well, thanks for being part of this podcast. I hope things are going well for you.